I'm going to speak now about ratios, which is a concept that's closely related to fractions and that we use quite a lot in biology, especially in genetics. So what am I talking about? I think I'll explain by an example. So here we've got 4 shapes. We've got 1 yellow square, 3 green triangles. So we could say that 1/4 of the shapes are yellow squares, and you could say that 3/4 of the shapes are green triangles. Nothing too controversial there. But we could also say that the ratio of yellow squares to green triangles is 1 to 3. So we have 1 as opposed to 1, 2, 3 triangles. So you could say there's a 1 to 3 ratio of yellow squares to green triangles. So that's 2 different ways of expressing the same thing. So here the denominator is equal to the total number of shapes. Here we don't have a denominator. And it could be more than 2 things that we're comparing here. You know, if we had some red circles, we could add those in as well. It doesn't have to be just 2 things. So that's all a ratio is, explained by an example. So we could also say, so let's imagine we've got something like that, and yes, we could say that 2 out of 6 of the sections of this rectangle are blue. We could also say that's equivalent to saying that 1/3 of the sections are blue, because we've just simplified the fraction. And we could also say 2 blue sections to 4 white sections, or we could say 1 blue section to 2 white sections. So I think it's nice to simplify ratios wherever you can. That's good practice. So something we often use ratios for is genetic segregation ratios. So you might do a cross of some plants, and in the F2 generation you would see, let's imagine, 910 short plants with yellow flowers. You could see 304 short plant with red flowers, 294 tall plants with yellow flowers, and 98 tall plants with red flowers. It's just some numbers I made up, and if we simplified and kind of squinted and approximated, and we can check that these really match the ratio that we're imagining mathematically, and you'll learn how to do that. But something you'll want to do to begin with is simplify and approximate those. So that would give you a 9, 3, 3, 1, which is a classic thing that you'll see quite a lot. So we would write that there's 9 to 3 to 3 to 1, with the colon in between each number.